All right, so I just kicked off with the recording now. I guess I will be handing the stage over to Chidera. Chidera, you could just proceed.
Okay, good evening, everyone. So
Yeah,
today I'm
good.
going to be taking you all on the Solidity fundamentals and intro to Remix IDE. So 1 second, let me share my screen. We have a lot to cover, so I'm going to be. Can you guys see my screen? Hello.
No, we can't see it
We
yet.
can't see your screen yet.
Yeah, I
Sure, you can
can
see
now.
it, right?
Yeah, I can
Okay,
now.
okay. So if for any reason you are not hearing me or my network disconnects, please just call my attention ASAP. So basically, we'll be following this book. I don't want us to go through the Solidity documentation because it's too
No, for
technical
now.
actually. So it's going to be easier.
No.
Sorry, I thought somebody wanted to say something. Yes, we have to continue. Okay, let's quickly um, go through this. We'll just be looking at what Solidity is, what a smart contract is, variables, constructor functions, interfaces, abstract contract. We look at a few contract examples. What's the contract state, state mutability, data locations, solidity data types. We'll talk about arrays, we'll talk about reference and value in solidity, error handling, inheritance, type conversion, hashing, API encoding and decoding, how to work with floating point numbers in Solidity, call contracts, and how to send and receive ether. Event logs, Solidity libraries, time logic, and I believe this is basically everything you need to know to start coding, to start building out your own smart contract. Um, like we said before, I mean, everyone here, I believe you should be very good with your JavaScript, TypeScript, or Python. At least that knowledge to, with Solidity because they follow the same paradigm, actually. Uh, okay, so Solidity is designed to be compiled, that's converted from human readable to machine readable code into bytecode that runs on the EVM. I believe you already know what EVM is. It's basically a runtime environment for Solidity code, just like your browser is a runtime environment for your JavaScript code. So let's move on. Now, what's a smart contract? Here's a simple smart contract that works out of the box. It may not look useful, but you're going to understand. Okay. So basically, this is how a smart contract is. You specify your license identifier, you specify the Solidity compiler version. Then smart contracts are just like classes in your JavaScript and Python. You know how classes work. You call the class, you call the name of the class, then inside of the parentheses, you put in all your logic, all your functionalities. That's basically how smart contracts are. Here, instead of using the class, you use the contract keyword, then you like give your contract a name. If it's an ERC20 contract, if it's a voting contract, just whatever name you want to give it, you specify it here. Then open your curly braces and every other thing that comes inside is going to be your um, your contract functionality. So we will get to some of the details like public and view. Okay, okay. For now, take 7 key lessons from the above example. The first comment is a machine readable line, SPDX license identifier. That specifies the licensing that covers the code. SPDS license identifiers are strongly recommended through your code, though your code will compile without it. So basically, this stuff here, this line of code here is how you specify your license identifier for your contract. If you have any license identifier for your contract, this is just like the this is how you specify it. You do the SPDX slash license slash identifier. Then after the colon, you just put the identifier. If it's MIT, if it's open source, if it's unlicensed, just put the license that you have there, just like how you do in your README for your complex JavaScript project. So moving on, you can read on about this later. Let's move on. The next one is the Pragma directive, which must be the first line of code in any Solidity file. So Pragma is a directive that tells the compiler which compiler version it should use to convert the human readable Solidity code to machine readable bytecode. Solidity is a new language and is frequently updated, so different versions of the compiler produce different results when compiling code. So in Solidity, it's a new programming languages for smart contracts. There are different versions. You could have some kind of functionality in version 1 that may be deprecated in version 2. You could have some functionalities in version 2 that may not be properly implemented, but will be better off in version 3. So this is how you tell your compiler that, okay, this contract that I'm writing, use this particular version to compile the contract, so it works accordingly with that particular version. This is how you do it. You specify your Pragma here, then you write the Solidity, and this small, I don't know what I'm going to call it, this raised to power, this small thing here, it basically means, okay, use any available compiler that is from 0.8.0 and above. So depending on the compiler, it could decide to use 0.8.9, 0.8.8.1, 0.8. You understand? So use any available compiler version that is from 0.8 and above. That's basically what this line of code is doing. So yeah, the next one is that semicolons are essential in Solidity. The compiler will fail if even a single line is missing. Usually your remix or your IDE is going to alert you. So you know how you write code in JavaScript and you don't close the line. It's not really necessary to close a line of code in your JavaScript. You could write some kind of functionalities and you don't put the semicolon to close that line of code. It will still execute. It's still going to work. Same thing with Python. But in Solidity, whenever you have an implementation, any code logic, you have to close that line of code. You have to close it with a semicolon so you don't have unexpected errors. Don't worry, we'll do a very, very simple practical on all of this, but we need to really move fast. Then the next one is the keyword contract. Tells the compiler that you're declaring a smart contract. If you're familiar with the OOP, then you can think of contracts as being like classes, like I said earlier. So you know how you define your classes in JavaScript and in Python. You write your class name, then the name of the class, then inside of the curly braces, you can start defining different functions and different implementations of your function. Then you can use that class in your other code on your front end to call specific functionalities. I believe that's how classes work in JavaScript. So that's exactly what's happening here in Solidity. Don't really look at this thing like it's all that complicated. You just have to, once you are done with this, you specify your compiler version. And after specifying your compiler version, you indicate that with this keyword, you are telling Solidity that, okay, this is a contract. It is not an interface, or it is not a variable that this is a contract. Then after that, you tell Solidity the name of the contract that you want to, the name of your contract, actually, whichever name it is, just write the name here. Then you open your curly braces. Inside your curly braces, you start writing your contract code. Yeah, functions are executable units of code that encapsulate single ideas, specific functionalities, tasks, and so on. So in general, we want functions to do one thing at a time. So you can basically take the idea of functions in your JavaScript here into Solidity. It's just like every function you see in a Solidity smart contract is like a block of code that performs a specific action at a time. So you can see this guy's own here. He has a variable, and he has a variable called qty corps. In this function, is trying to get the value of that variable. You can see you write your function, the name of your function, visibility, and inside of your function, you write whichever logic that you want to implement inside of the function. This one is trying to increment the value of the state variable here. This one is trying to decrement the value of the state variable. So this is basically what smart contracts are all about. Every single function is like responsible for a specific computation. More on that much later. In the above example, the variable qty corps are called a state variable. So any variable that is being declared outside of the functions are usually state variable. In JavaScript, I believe it's they call them global variables, if I'm not mistaken. It holds the contract state, which is the technical term for data that the program needs to keep track of to operate. Unlike other programs, smart contract applications keep their states even when the program is not running. The data is stored on the blockchain along with the application, which means that each node in the blockchain network maintains and synchronizes a local copy of the data and smart contract on the blockchain. So that's pretty much self-explanatory. Now, how to declare states, how to declare variables and functions in Solidity. I hope you guys are still with me. Hello?
Yeah, sure, with you.
Okay.
Yes, sir, with you.
Now, how to declare variables and functions in Solidity. Let us break down the hot fudge source smart contract so we understand. Okay. The basic structure to defining things in Solidity is similar to other statically typed languages. You give functions and variable a name. But in typed languages, we also need to specify the type of the data that is created, passed as input, or returned as output. You can jump down to the typing. Okay. Below, we see what declaring a state variable looks like. We also see what declaring a function. So basically, this is how you declare a variable in TypeScript. Sorry, in Solidity. First of all, you declare its data type, then you specify its visibility, and then the name of that variable. The first thing first, you specify the data type of this variable. This one is a uint, an unsigned integer. You specify the visibility. If you want it to be public, that is public variables, everybody can access it, be it the current contract, be it the child, any contract that is inheriting from this contract, be it an externally owned account, which we covered in the last class, your usual wallet addresses. Anybody has access to this variable if you mark it with public. We're going to we'll look into that when we get to visibility modifiers. Then the name of the function, the name of the variable. This is basically how you specify variables in Solidity. Because it's a statically typed language. It's not like JavaScript where you just do your var, the name, and anything that you give to it. You must specify the data type. Then this is how you specify functions in Solidity, the function keyword, the name of the function, you open parentheses. Then you also need to specify the visibility modifier. You have to specify the state mutability. Here, you usually have view and pure functions. Then you also have to specify the returned data type. If your function is going to return anything, you have to specify the data type that is being returned. If you're familiar with TypeScript, right? We have something like this in TypeScript, where if your function is going to return, let's say it's going to return an integer, you have to mark it with a colon of integer. If it's going to return a string, you have to mark it with a colon of string outside of the when you close the brackets, you just do your colon, then the name. If it's not going to return anything, you still have to do the colon, then with the void keyword. It's exactly the same thing that is happening here. So the first, okay, we've already explained all these ones. Okay, it is worth noting here that state variables can also be of other types, constant and immutable. They look like this. So aside having the other types that we saw above, you can also have state variables to be constant and immutable. Usually, when you mark any variable to be constant or immutable, it means that you cannot change that variable later. You cannot change the variable. You cannot change that variable to something else later. 1 second. Constant and immutable variables have their values assigned once and only once. They cannot be given another value after their first value is assigned. Exactly. So this is quite different from the usual changing of values, where let's say now we have a uint of let's say a uint age, right? And at first we assign that age variable to be 20. And somewhere in our code, much later in our code, we are doing some kind of calculation and we are updating the value of that age variable from 20 to maybe 25. That's going to work. But if you should specify this constant or immutable keyword to that variable, it's going to throw an error because there's no way you can change it. Things like this, you can use this kind of thing if you are building a contract that maybe you want to store a particular address to only have access to specific functions. You want your contract has maybe a tax. Maybe you are building an ERC20 token and you have a tax of 2%, right? You don't want to change it. You don't want anybody to change it. So you can mark that thing with constant or immutable. Let's move on. Okay. Variable scope in smart contracts. You have the states, you have the local, you have the global, right? The state variables, they are usually permanently stored on the blockchain, right? The local variables are transient pieces of data that hold information for short periods of time while running computations. These values are not stored permanently on the blockchain. The global variables, these variables are functions that are injected into your code by Solidity and made available without the need of, okay, basically your state variables are usually, it's just like your global variables in JavaScript. Whatever variable you specify outside of a function, those are usually state variables. Variables outside of functions, they are state variables and they are stored permanently on the blockchain. Then any variable that is inside of your functions, they are usually limited to that function scope. Then your global variables are just like they are just like natural variables that are being provided for us by Solidity, so we can directly interact with the blockchain. Like if you want to get the address that is calling your contract or is trying to interact with a particular function in your contract, the global variable there is usually msg.sender. If you want to get the timestamp of a particular transaction, usually block.timestamp. If you want to get the origin of a transaction, usually tx.origin. So I guess I should share this so everybody can look at them later. So you can use that to get acquainted with the various global variables we have in Solid. Hold on, I think they even shared some here. I think this is better because it's coming directly from the Solidity documentation. So let's move on. You can tell the differences between the scopes as follows. So state variables are generally found outside the smart contract, but outside are found inside the smart contract, but outside of a function. I've mentioned that local variables are found inside functions and cannot be accessed from outside that function scope. Then global variables aren't declared by you. They are magically available for you to use. So here is a Hugging Face sample, Hugging Face source example, slightly modified to show the different types of variables. We give quantity cups is starting value. Okay, so here they've modified the contract actually. You can see that these two things here, they are the state variables. Let me zoom in so you see. These two stuff here, they are the state variables and they are permanently stored on the blockchain, right? These are your function. These are your functions, and you can see a variable declared inside of this dispense function. Usually it's called a local variable. It's not stored on the blockchain. It's only made available and stored in the memory of your EVM when this particular function is being run. Yeah, so you can also see how you can mutate the values of your state variables inside of any functions. So let's move on. How visibility specifiers work. The use of the word visibility is a bit confusing because on a public blockchain, pretty much everything is visible because transparency is a key feature. But visibility in this context means the ability for one piece of code to be seen and accessed by another piece of code. So visibility specifies the extent to which a variable, function, or contract can be accessed from outside the region of code where it was defined, right? So basically, all this big English is more like visibility is just a way you can uh, control the level of. It's just a way you can control the how do I say it? Just a way you can control the people or the level in which certain entities can access your smart contract or your functions, right? So in Solidity, you have 4 different types of visibility. You have the public, you have the external, you have the internal, and you have the private. So public functions and variables can be accessed inside the contract, outside it, from other contracts, and from external accounts, your EOAs, like your MetaMask accounts, pretty much from anywhere. Is the broadest, most permissive visibility level. So if you mark your functions or variable with the public keyword, right, everybody basically has access to it. Let's move on. So the private functions and variables are only accessible within the smart contract that declares them, but they cannot be accessed outside of the smart contract that encloses them. Private is the most restrictive of the 4 visibility specifiers. So as opposed to public, where basically everybody can have access to that particular data. If you mark any function or variable with private, it can only be accessed within that your smart contract. Contract inheriting your smart contract cannot access that function or variable with the private keyword. Your externally owned account cannot access that variable. Then you have internal visibility. It's similar to private visibility in that internal functions and variables can only be accessed from within the contract that declares them. But functions and variables marked internal can also be accessed from derived contract, that is child contract that inherit them, but not from outside the contract. We will talk about, okay, so basically your internal visibility, just like your internal functions and variables, just like marking things with private. The only thing is that your internal functions can actually be accessed from your child contract. If there's any contract that is trying to inherit, I mean, you must understand the concept of inheritance in object-oriented programming. So if you have any contract that is trying to inherit your particular contract, any functionality you have that has a internal visibility will also be accessible to them. So for a better understanding of this thing, I think this image is quite explanatory. You have the public, you have the private, you have the internal, and you have the external, right? The public functions and variables, they are accessible within your contract. They are accessible outside your contract. They are accessible by child contract, any contract that is inheriting from your contract. And they're also accessible by external accounts. External accounts here again is your personal accounts, your EOAs, your addresses in your MetaMask. So your private functions are only accessible within that contract. Your internal functions are accessible within the contract and your child contract. So any contract that is inheriting from your contract can also access your internal functions. Then you have the external functions. They are only accessible outside of your contract and your external accounts. So that's basically what the diagram is trying to explain. You understand all these things later when we start doing the practical. Okay. So the external visibility specifier does not apply to variables. Only functions can be specified as external. So yeah, let's move on to constructors. A constructor is a special type of function. In Solidity, it is optional and is executed once only on contract creation. In the following example, we have an explicit constructor and it accepts some data as a parameter. Okay, so this is how you specify constructors in your Solidity smart contract. You use the constructor keyword, you open a bracket, and inside of the bracket, remember, whenever you want to specify any variable, first of all, the data type here is they're using the memory location and the name. Let me explain something. When you are creating a variable in Solidity, if it's just a variable, not some parameters inside of it that are needed in a function. If it's just a variable, what you need is the data type, the visibility, and the name. But if it's a parameter, let's say this is a function, this is actually a function. But if it's a parameter, all you need is your the data type and the name. This is just like memory location, which is usually used for strings and bytes and some other things. We'll get to that much later, but you don't need visibility specifiers inside of the parameters. You put the visibility outside of the parameters. Whether it's when you enclose your bracket, then you specify the visibility here. This is to show where exactly this particular function can be called. So coming back to what we are talking about, constructor functions is just like they are run once they are run once during when you want to deploy your contract. The constructor functions are usually what's being run, and then they help you set your state variables. So you can see this constructor function. We are creating a constructor function which is basically going to like set the state of this contract. So that's basically it. To understand when the constructor function gets called, it's helpful to remember that a smart contract is created over a few phases. It is compiled down to byte code, and this phase is usually called compile time. It is created. This is when the constructor kicks into action. This can be referred to as construction time. The byte code then gets deployed to the contract. The deployment, then the deploy contract. So basically, you know how, like Darlington explained the last time, when you are deploying your smart contract, all the whole logic you've written is basically being compiled down to bytecode, and then that is the specification the EVM is going to use in executing your contract. So when you are writing your smart contract, if you have any constructor function with parameters, that is what is being run first. Then after it's being run, then the other stuff are being compiled into bytecode. Whatever you save in your constructor function will be set in your state variable. Then other things will follow from there. Okay. Yeah, but I've explained all these ones. Yeah, so I've already explained all these ones. Basically, you are passing in the name and setting it here to the state. Then understanding the why, you might wonder why we bother with injecting values into the constructor. Why not just write them into? This is because we want contract to be configured or parameterized rather than hard code values. We want the flexibility and reusability that comes with injecting data as when we need them. Okay, so let's move on. You can these ones are pretty much not important right now. Just know that constructor functions are functions that are used in setting state variables. Um, okay, interface is an abstract contract. Or should I even do a practical of this constructor? I don't know if you guys are confused. Any questions so far? So before I move on, let me just introduce you to the whole remix interface. I mean, it's already very simple to work with. Here, this is basically where you have access to your file folders. It's just like your usual Visual Studio Code IDE. This is where you do a global search. This is your compiler. So here you can select whichever compiler version that you want to use to compile your code. You could choose to do auto compile. You could choose to hide warning, whichever one is best to do things manually on your own first, so you can understand how things work. Yeah, this is the compiler. After writing your Solidity code, you come here, and compile your code. And after compiling, this is where you deploy your smart contract. If you have any error, this is where you debug your smart contract. So basically, let us take an example of the So let's declare a state variable here. In 256, let's make it public and let us set it to owner, right? Okay, let's leave it first then. Currently, we are just declaring this state variable. There is no, we are not assigning a value yet. So that is one of the importance of having a constructor function. Let's say you are building, you've been contracted to build a contract, right? A smart contract for some individuals or a company, and you don't know all these values. You don't know who is going to be the sole owner of the contract. You don't know, maybe there are some other things that will be needed in the contract that you are not sure of. That is where you have your constructor function. So when you want to deploy, you can reach out to them and say, okay, um, um, I'm done with the contract. I will need this specific information. So instead of having to go back to your code, scrolling through everything to change it, you could just set the values at deploy time. So let us maybe say public to be, I don't know, maybe this should just be, so let's deploy a constructor. What's going on here? Okay. Anybody else can question? Yeah, you can ask your questions.
Yeah, thank you. So when you are declaring this unsigned integer variable, so can you hear me?
Yes, I can hear you.
Yeah. So you said unsigned integer 256. Meanwhile, in the examples you have been showing us in free code count, they didn't actually write any number after the unsigned integer. Why is that?
I don't understand. Can you come again? Hello, can you come again?
Yeah. So, I mean, when you are declaring your state variable, right? They
Mm-hmm.
used unsigned integer 256, right?
Yeah. No.
So, but
This was a mistake. This was a mistake. This is not supposed to be an integer. It's supposed to be a type of address. Yeah, continue.
okay. Again, this state variable called amount in savings. Yes.
Yeah.
Are we supposed to be adding numbers in front of this unsigned integer keyword?
Adding numbers, how?
Like in the examples he showed us in our freecon camp handbook, yes, they didn't use. They just said unsigned integer. They didn't add any number in front of this keyword.
Okay. So they put it like this, right?
Yes.
They just made it you. Okay. So it depends on the person's design decision, right? Basically
Design
putting the
decision, right?
specifiers u int, putting the specifiers to u int 8, it just depending on the amount of. Can you mute your mic? So if it depends, if you put the uint without any without any number value, it depends. It's going to be dynamic. But when you know the actual amount of um, integer that is going to be saved in this particular value, then you could assign it appropriately. If it's a value that is going to be a uint of 8, you can specify it to be uint of 8. If it's a number that, if it's going to be a very large number, then you can put it to be uint 256, right? Usually, it's best to always specify the integer itself. That way, it's going to save gas. We will get to gas optimization much later in the course.
All right. Thank you.
So yeah, here we are creating a constructor functions, right? We are creating a constructor function, and we have a parameter of address owner and uint 25 uint 8 of amount. You can actually use anything. You can set anything. Then inside of this constructor function, once we want to start setting our variables. This is basically how you set variables in Solidity. So you call the name of the variable that you want to set, then you pass in your parameter in there. And the next one is this one. So this is basically how the constructor function works. One thing I forgot to add is so when you mark any state variable with the public keyword, automatically it's going to create you a getter function. The getter function is just basically a function that helps you get the value of any variable here. So instead of we probably writing a function that gets the value of say owner, maybe say get owner, right? Instead of us doing this one manually and say return owner, instead of doing this, because basically what this function is going to do is it's going to help us get the value of this state variable, but we don't really need to do it since we already have the public keyword here. Automatically, Solidity is going to help us create a getter function. But let me leave this one so we can use it to explain how those things work. So let's go to our compile tab and compile. Hold on, I think there's an error. Hmm. Let's be identify. second. Okay, remember that we are trying to return something there. And
I was actually going to point this out, but
sorry?
Sorry, I was just saying I was going to say something about the error, but I wasn't sure, so I kept quiet.
Okay. That's part of. I don't know why this thing is throwing an error. So let's return this one. We'll get back to all those errors because we have many other things to deal with right now. Okay, this will still work. We need to compile and then right. So this is how you deploy your contract if you have a constructor function. Here, it's already telling us to pass in the owner and the amount int value, right? Let me say this is going to be the owner. Okay, when you are deploying the smart contract, you could decide to use injected provider. If you use injected provider, it's going to connect to your MetaMask wallet, right? And then it automatically determine if I should zoom in, automatically determine your the network you're currently connected to. Currently, I'm connected to Guali, so it has selected Guali as the network. If I should change the network to say Sepolia, you can see it has automatically changed the network to Sepolia. So I don't want to use injected Web3 right now because it's usually slow. We need to move fast. So let me just use the normal Remix VM. These are just basically virtual machines that are provided to us by Remix, and we can use them for testing purposes. When you select any of them, they provide you with a whole bunch of addresses and 100 ether for you to do your testing. They are not real money, they are just testnet money. So here we are selecting the contract that we want to deploy, which is an example.so. And before we deploy, we have to fill in these values, which is basically the constructor. So this is where you can ask whoever that is asking that sent you to build the smart contract. You can ask them, okay, who is going to be the owner? They send you the owner address, you paste it in here, and the amount in, maybe this is some kind of value or something. You could maybe say 2, right? And then transact. What this has done is that it has deployed the contract for us. And the good thing with Remix is that it provides you with an interface so you can easily interact with your contract, right? So this is the function get owner. Now see that thing I was talking about, if you should mark any variable with the public keyword, it's going to create a getter function for you. So basically, we can now see the values of what the owner is. You can see the value here, which is what we passed in. Then the amount in is the 2. If remember these two things are our two state variables, and this one is the function that I created here. So this function, what it does is it basically returns the value of this state variable. So you can see it here. Basically helps us return the value of our state variables. That's why I said it's usually not needed since we mark our state variables with the public keyword. It's Solidity automatically creates a getter function for us to see them in our interface. Probably in the even in Etherscan, you can see those functions there and you can interact with them. So that's basically what the constructor function does. It helps us set our default state variables before we can deploy our contract. So I hope that's clear, because it's one of the key aspects of Solidity. So where did we stop? All right, so moving on to interfaces. An interface in Solidity is an essential concept to understand. Smart contracts on Ethereum are publicly viewable, and therefore you can interact with them via their functions. To the extent the visibility specifiers allow you to do so. Okay, this is what makes smart contracts composable, and why so many DeFi protocols are referred to as money Legos. So you can write smart contract that interacts with other smart contract that interacts with other smart contracts, and so on. So when you want your smart contract A to interact with another smart contract B, you need B's interface. An interface gives you an index or many of various functions available for you to call on a given smart contract. An important feature of interface is that they must not have any implementation, that is code logic, for any of the functions defined. Interfaces are just a collection of functions, function names, and their expected arguments and return types. They are not unique to Solidity. So in smart contracts, whenever you're building a smart contract, usually there's what is called an interface. It just provides you with a kind of function signature of how you can interact with a particular smart contract, right? This is how you specify the interface of any contract. Usually your Pragma, Solidity, and everything. Then instead of the contract keyword, you're using interface, and usually interfaces are prefixed with an I, then the name of the contract. Then inside of curly braces, you specify the functions that can be called in your contract, right? Usually, I believe this guy is wrong, but usually instead of public, you can usually, the visibility specifier can be public or external. That way, other contracts can like import this interface and use it in their own functionality. So that's it. Hotface source had only 3 functions. The interface shows only those. So these are the functions that the interface shows. Other contract now can start interacting with this hotforge source contract. But there's an important and subtle point here. An interface does not need to include all the functions available to call in a smart contract. An interface can be shortened to include the function definitions for the functions that you intend to call. If you only wanted to use the decrement method on this smart contract, then you could absolutely remove this and this from your interface, but you would not be able to call those 2 functions from the contract. So basically, whenever you are specifying an interface for your smart contract, right, you really don't need to put all the functions that are accessible in that contract. You only need to include the functions that you want to call. So in this place now, you said if we only want to call the decrement method, we can do away with these 2, right? But at the same time, it does not matter. It really does not matter. You can put everything and call only one function. So that's up to you. It's only in abstract contracts that you need to do some kind of implementation. So, okay, an abstract contract is declared using the abstract keyword and is one where one or more of its functions are declared but not implemented. This is another way of saying that at least one function is declared but not implemented. Flipping that around, an abstract contract can have implementations of its functions, unlike interfaces which can have 0 implemented functions. But as long as at least one function is unimplemented, the contract must be marked as abstract. So as opposed to interfaces, if you want to deal with an abstract contract, you use the abstract keyword, then the name of the contract, and the abstract keyword, the contract, and the name of the contract. Then, so as opposed to interfaces where you just need the function and just the functions, right? in an abstract contract, you can actually have some kind of implementations within your functions. So 1 second. Yeah, you may legitimately wonder what the point of this is. Well, abstract contracts cannot be instantiated directly. They can only be used by other contracts that inherit from them. So abstract contracts are often used as a template or base contract from which other smart contracts can inherit, so that the inheriting smart contracts are forced to implement certain functions declared by abstract or parent contracts. So this is usually important if you are building some kind of complex applications and there are multiple people in the team, right? You can use abstract contract to like create a kind of base layer where every other team members they must follow this particular design decision. They must use these specific functionalities within whatever contract that they are building, because everybody basically have their own different design implementation. So if you are building a complex application and there are multiple people involved, you could actually use define an abstract contract with the functionalities you need, and every member that's working on different things could actually inherit from these contracts, and whatever implementation they are doing, they are making it to be in line of what you have here. So that's the importance of some of the differences between interfaces and abstract contracts are that interfaces can have zero implementations, whereas abstract contracts can have any number of implementations as long as at least one function is abstract. That is at least if one of the functions are not implemented. All functions in an interface must be marked as external because they can only be called by other contracts that implement them. Yeah, this is what I was saying earlier, that usually interfaces are marked with external. So interfaces cannot have constructors, whereas abstract contracts may have. Then interfaces cannot have state variables, whereas abstract contracts may also have state variables. So smart contract example, this one is basically using use the smart contract. I don't think we need to go through this one because this is basically a chain link Oracle smart contract. Yeah, we really don't need to go into Oracle right now. That's like going to be our last class for the session. So let's just move on and pick everything that we need. Talking about chain link Oracle, 1 second. All right, let's move on. Just whenever you are reading, leave this part, or you can actually read it if you want to, but we are going to go into oracles much later in the class. We don't need to become too technical right now. Let's understand the basics for now. So what is contract state? Before we proceed anything, important to make sure that the terminology that we are going to see is okay. Stating, okay. The cross of states is that it refers to all information that is remembered by a program as it runs. The information can change, update, be removed, created, and so on. So if you have to take a snapshot of it at various times, the information will be in different states. So the state is just the current snapshot of the program at a point in time during its execution. What value do its variables hold? What are they doing? What objects have been created? So basically, when you are talking about states in Solidity, in smart contracts, in Ethereum, just like the state of the machine at a particular point in time. I believe you all remember what was taught in the EVM, which is it's a Turing complete state machine. So at every period of time, it's taking a snapshot, it's like munching a snapshot of every single thing that is happening on the blockchain as things are being changed from one state to another. So you make a transaction. I send 1 Ether to Darlington, right? The EVM is going to like hold this, the EVM is going to hold the state from which I sent that ether to when Darlington received the ether. So when that transaction is completed, the state of the whole EVM changes. So that's basically like on a surface level what state is all about, and it applies to the contract itself. We have previously examined the three types of variable: the state variable, local and global. State variables along with local variable give us the state of the smart contract at any given point in time. So the state of a smart contract is a description of what value its state holds, what values the blockchain related global variables have at that moment in time, and the balance, if any, lying in the contract. So state in terms of the smart contract is basically giving us information of the values, the value of the state in that particular contract, right? The value of the state variables, the value of the blockchain related global variables. Like if there is any particular address that makes a function call, it tells us that at this point in time, this particular address made this particular function interaction. Then if there is any money that's been sent into the contract, or if there's any money that the contract is holding, if it's 10 ETH at that particular state, at that particular point in time, the contract is like holding a snapshot of it. So that's basically it. That's basically what the EVM does, just like a state machine. Like it keeps hold of every state and distributes the whole copy to all the node operators. So state mutability keyword modifiers. Okay, so this keyword are referred to as modifiers, but not all of them permit you to modify the state. In fact, many of these expressly disallow modifications. So this is basically all the modifier keywords in Solidity smart contracts. You have the constant applies to only state variables. You can see the purpose declared and given the value once. At the same time, hard-coded into code. Its given value can never be changed. Immutability also applies to state variables only. These are declared at the top of smart contract, but given their value only once at construction time. So the next one is the view keyword, right? It is it applies to functions. You generally see this right after the visibility specifier. A view modifier means that the function can only view from contract state, but cannot change it. This is effectively a read-only modifier if the function needs to use any value that is not. So basically, if you mark any function with the view keyword, it means that you are reading from state. You are not modifying the state, right? In this particular function now, I could decide to mark this as a view function because it is reading from state. It is not modifying the state. I think that was even why it was throwing an error there. Yeah, so I could mark it as a view function. We have view and we have pure function. View functions, basically, they are only like returning the value of whatever you have in the state to you. You understand? So that's basically what this is talking about. Then you have the pure. Functions that are pure are not allowed to write to the state, nor are they allowed to even read from the state. They do things that do not in any way interact with the blockchain state. Often these can be helper functions that do some calculation or convert an input from one data type to another. So as opposed to the view modifier here, if I should use something like a pure modifier, right? It does not read from states. It does not write to states. Basically, it just helps us to do some kind of computations. Let's say we have this to be equal to 1, and let's say we have another. So you can basically do 2 + 1 to be 3, and From there, that's as expression has to be an. Sorry, 1 second. So basically, this is just like if you are using a marking anything with the pure keyword, you can just use it to do some kind of calculation. As opposed to the view, which is just you marking the function to be like kind of allowing you to read from the state. So the next one is payable function. So the payable is just allowing you to like if you mark any function with the payable, it allows you to like receive ether to your contract. This keyword enables a function to receive ETH. Without this keyword, you cannot send ETH while calling a function. So yeah, if you have a function that is going to be like send ether, you have to mark it with payable keyword. Say for example, you have something like send, and you can maybe make it to the public, you can make it to be payable, and you can do your calculation inside of your you can do the calculation that helps you to send ether, not tokens, ether into this particular smart contract. So the next one is which one? You have virtual. This is slightly more advanced topic and is covered in detail in the next session. This modifier allows the function to be overridden in its child contract that inherits it. In other words, a function with the keyword virtual can be rewritten with different internal logic. So if you have a function, if you have a smart contract, right, and it has its own functionalities, you could decide to mark your function with the virtual keyword. And when you mark your functions with the virtual keyword, it allows contracts that are inheriting from your contract, it allows them to be modifiable, if that makes sense. So the override keyword also works hand in hand with the virtual keyword. Now, let's say you are writing a new contract and you want to inherit some functionalities from your previous contract. So in that particular function that you want to override, you mark it with the override keyword. And since that function already has, since the parent function already has the virtual keyword, it will allow you to override it and do your own modification inside it. Then index, this one applies to events. We'll get into that much later in the course. Then anonymous also applies to events. Let's quickly move on. So data location, you have the storage, you have the memory, you have the stack. So data locations are part of the fundamental design and architecture of the EVM. When you see the words memory, storage, and stack, you should start thinking data location. That is, where can data be stored and retrieved from? So let's basically, when you talk about storage, memory, and stack, right? The storage data location, any data that is being stored in this particular storage, it's being permanently stored on the blockchain. Just like how you have your state variables, they are stored in the storage location, and your memory, any data that is being any data or variable that is being stored in the memory, it's only stored temporarily and only exists when that particular function is active. So if you have some kind of function that you specify the memory variable within that function, it only exists when that particular function is being called. It's not going to be stored to the blockchain, because there's one thing about the EVM. So the EVM being a virtual machine, it's not like it has its own size where when you deploy your contract is going to be included in the memory of the EVM. Instead, whenever you are deploying a contract, right, the EVM creates a storage for your particular contract. Let's say I deploy a contract, the EVM creates a storage for my contract. If Musa deploys a contract, the EVM creates a storage for his own contract. If a million other people deploy a contract, EVM creates a storage for the contract, and there is a max size of, I think, 24 bytes for every smart contract. I'm not really certain, but you can look that up much later. So this is just how you can write to and retrieve information from the state. Any state variable have been stored in the storage and they are stored permanently on the blockchain. Any variable that is marked with the keyword, they are only they're only available when that particular function is being run. Then the stack is just like a kind of data structure that the EVM uses, right? The it's just like the kind of data architecture in which the EVM uses, where every data is being stored in a stack-like way. I don't know how to put this into perspective. Who is familiar with the stack data architecture here? Hello, can you guys hear me?
Yeah, we can hear you.
So anyway, the stack is just like the kind of data architecture that the EVM uses. So every information is being stored in a kind of stack-like way, where there's a kind of block for every single data. You have block one information is there, you have block two, another information is there. On top of block one, you have another block again, another information is there. So if you want to access the information that is like under, like maybe in block one, you have to remove block three, remove block two to get to that block one information. So that's basically how the EVM processes things. Then that thing again is more important. So how typing works. This is just specific. This is just to explain to you how we do typecasting in Solidity. So you know this is going to be JavaScript, I believe. Okay. So you know how you do typecasting in your JavaScript. You define a variable and you assign it to an integer of 1, right? Tomorrow you could decide to change that variable and assign it to maybe a string, and it's going to work. But in Solidity, this is not going to work. Instead, there is a way you could typecast things in Solidity. So, 1 second, I'm trying to find. When a language has strict type, it means that the language strictly defines what each piece of data type is, and a variable that has a type cannot be given another type. In other words, in strictly typed languages, you have the int of 1. This is already an integer. Then you have the string of b. This is already a string. If you want to change this b to a, it's literally not going to work. Then, but in JavaScript, there is, which is not typed, b equals to a would totally work. This makes JavaScript dynamically typed. Similarly, in statically typed languages, you cannot pass an integer into functions that expect a string. But in JavaScript, you can pass anything to a function. And okay, so this is not the part where I was explaining. But basically, what this thing is just trying to say is that whatever data type you assign to a variable in Solidity, that is the data type you have to use throughout the lifetime of that particular contract. Yeah, I think that's what this part is covering. How to see the other one. So the Solidity data type, we have need to go straight to what Solidity data types are. So many of Solidity's primitive data types are variations of same base type. For example, the int type itself has subtype based on the number of binary digits that the integer type can hold. Anyway, when we want to talk about the Solidity data type, we have to also talk about the pass reference versus the pass by value. And here they did not really go deep into it, but we'll get to this one. But before we get to the data type, let's first understand the pass by reference and pass by value. At an OS level, when a program is running, all data used by the RAM during its execution is stored in locations in the computer memory. I hope you're all with me. If you are confused about anything, it's better you ask now so we can trash it once.
We are following for now. I am following for now.
Okay, I think there are some questions. For example,
I'm
which
following for now, but I think you're too fast. A bit fast.
Okay, I'm just trying to, because there is a whole lot of
Please, me at
things to
some point
cover.
I'm lost.
So,
I was following, but at some point I'm lost. This is kind of trying to get the hang of it, sir.
okay, what part? What part are you lost in?
Initially, so let me not just draw it to back. Initially, it was all those time you made mention of all those trying to bring other tools good. I think under that abstract and teaching us about abstract. But now, so I'm trying to get the concept of all these pass by value and pass by uh, reference. I understand it in JavaScript, sir, but I don't know how it applies here. Then, speaking of when we are talking about those, when you are writing those remix code, I didn't get the hang of it better. Like I'm still trying to push everything in, but I didn't
Okay,
get it.
okay,
That's true.
okay. So for the interface, right? You said you lost us on the interface and the abstract. So
Yes,
I was saying
exactly,
that
exactly,
interfaces is
exactly.
just like a way we provide a specification for other smart contracts to interact with our own smart contract, right? So if I have a contract, right, like this is a contract, this is a contract, this is the function that I have inside of this contract. I have a function called get owner. I have another function called send, right? If I want other contracts to interact with this particular contract, what I'm going to do is that I'm going to specify the interface. So to specify an interface, all you need to do is you use the interface keyword, then the name of the interface. Whenever you are writing an interface, usually you have to prefix it with an I, a capital I, and then the name of the contract. So interfaces, you don't need to have the state variable. It does not also need to have, it does not need the constructor. All it needs is just your functions. And remember, you have to close everything. And it with the external keyword, sorry. And so this provides an implementation for other contracts to inherit from your contracts. When we get to inheritance, we look at how other contracts can interact with your contract through an interface. Then when we talk about an abstract contract, right? An abstract contract, let us say, in an abstract contract, the difference, let me just quickly write this down. 1 second. The difference between an abstract contract and an interface is that in an abstract contract, you could have an implementation, you could have some kind of code logic inside of your functions, right? You could also decide not to have any logic inside of your function. You can leave a function without an implementation, but in your interface, you just need the function signature. That's everything you need for your interface. And we said that whenever you are writing, the reason why we need an abstract function is in terms, maybe if you are working on a kind of a complex application, right? You are working on a complex application and there are multiple people in the project, right? You need everyone to follow a particular design system. You don't want somebody to come and write get owner in the main contract and start changing things. You want them to follow a particular convention. So you could you could define an abstract contract for them to inherit. When they inherit from this abstract contract, then they can start using this implementation, these functionalities, and start writing their own code in there. So the pass by reference, Peter, you want to ask? You
Please,
want to
I
ask
have
a
a
question?
question. Yes.
Yeah, move on.
Okay. Is it that
Thank you very
the
much.
with
Thank you.
the abstract they can edit the functions in the abstract? Is that the point of using the abstract?
Yes, if you have an abstract function, you can edit the functions in your abstract. Like people that whenever they inherit that abstract function, they can edit the functionalities in there.
Okay,
But
okay, that is with interface they cannot edit it. Oh, okay,
no,
okay, I
no,
get it now.
no, the interface just
Thank you.
provides a kind of, you know how what interfaces are. You just in normal programming, interface just provides some kind of implement for you to like be able to interact with something, right? So in interface in Solidity is basically the same way. It just provides you with functions that can help you interact with a particular smart contract. So an example is just like I build a smart contract that helps me transfer tokens, right? And I deploy that contract to the Ethereum blockchain. When I deploy a contract, it's going to give me a contract address, right? Now, when I get that contract address, I could go into my code, right? There's a way they do it. When you deploy your smart contract, you get the smart contract address. Then, using that smart contract address, you can also import the smart contract interface if there's any interface available for that smart contract. So through the interface, you can start using the maybe when you save that contract address to a variable, let's say address. The name of the variable is an address. You are using TypeScript now. Let's say it's an address. Then you get the address. When you put your address dot, you see all the functionalities there. You understand? So you can use that functionalities now to start interacting with your contract. I think we will get to that much later in the course. So you see practical example of how it's being used.
Sorry, I still have a question.
Okay, move on.
Please, can you clarify me on the difference between constant and immutable modifier keywords?
So constant and immutable, basically, if you mark any, they are basically the same thing. They are basically doing the same thing in the sense that you cannot change their values whenever you've assigned them, right? If you should write any if you should assign any value to anything that you call a constant, it's not going to be changed. You can't change it tomorrow. You can't change it in your contracts at any time. You understand? So that's basically what it's all about.
All right, thank you.
Yeah.
Sorry, can I ask a question?
Yeah, go ahead.
Okay, I'm confused in terms of I don't know, is smart contract itself like a back end? You get my question?
So when it comes to yeah. So when it comes to blockchain development, we want to see that's basically what when you come to full stack Web3 development, your smart contract basically is your backend, right? Because it
Okay.
provides you with functionalities on how exactly your front end should even work. It provides you with your databases. If you are familiar with backend, you have your database where you can store information and retrieve information at any time. So your smart contract helps you store information to the blockchain. The blockchain will be your database. You understand? So you could send information to the blockchain and retrieve the information from the blockchain and do some kind of manipulation in your front end. So basically, in full stack Web3 development, if you're a full stack Web3 developer, usually we see the smart contract as a backend for our application. Then the front end is there on its own. The smart contract is just like the middle layer, which provides us with everything. Then usually you have the ABI, application binary interface. Whenever you deploy a smart contract and verify it on the blockchain, right, you are provided with an ABI. It is not that ABI that is going to it's going to be like a kind of how do I put it? In backend development, maybe you could call it a RESTful API, which helps you to
Okay.
get posts and everything. So that API helps you with the functionalities you can use to call some kind of functionalities in your contract, save data to the blockchain, retrieve data from the blockchain as regarding that particular smart contract. So that's basically what it is.
Okay, thank you.
So any question before we move on? Because I'd like to explain this reference time, so at least before we close for today. Any question? I hope I'm still. Hello.
Okay, yeah. Are we done with the data locations?
Yeah, we're done with the data location.
Okay, I think I'm lost a bit in it. I don't know if you
Okay,
can.
ask your question. You can ask.
Okay, I don't get the difference between the storage and the memory. Can you come again?
Okay, the storage data location, right? Whenever basically, you know, everything we've talked about concerning the state variables, right? Now, the state variables are being stored in your smart contract storage. Any data or variable that is being stored in the smart contract storage, it lives permanently on the blockchain. Let us say, for example, what we have here, these are our state variables, right? They are being stored in the storage. Then, if, for example, we have if for example we have a memory, let me quickly show you something. Maybe this is a struct of a person. No, these are advanced data types, but we'll get to that much later. This person is going to have an age, right? You want to know the age of the person, you want to know their name, right? Name. So when you have this, you could maybe define a mapping, takes in a key of address and a value of say this particular struct now. So this is going to be public and this is going to be say people. Okay, now if to explain this thing, set person doing 256 age. Here the memory is going to come up. So remember these are state variables, right? And it's being stored permanently on the blockchain. When you are dealing with structs, this is when memory actually comes into play, right? Now we want to call this struct, which is a kind of custom. Struct allows you to create your own custom data types. So you call the person, which is already a data type now, and you call the memory, and you can assign it something and say, okay, which will equal to these people mapping, and let's say msg.sender. Right? Now, what this thing is doing is that it is saving this variable to the memory of this smart contract, right? And this thing will only exist while this smart contract is running. This particular function is running. So now I have a variable of p, and I can use this p now to start assigning things to this age. You can put age p dot. You understand? This p is not going to be stored on the blockchain. It's not going to be there permanently. It only exists because we are making a reference to this particular struct. You understand? So it only exists then, and as we are assigning these variables to this struct, it's now saving it to the state. I don't know if the explanation makes sense. Don't forget about this mapping for now. We'll get to that for now. I want to explain the difference between that storage and memory. These are storage locations. Your state variables are stored in the storage of your smart contract. This memory, right? Whatever variable that is being stored in your memory is not stored permanently on the blockchain. It only exists when this functionality is being active, right? And whenever this functionality ends, it is being destroyed. It's not going to be useful at all. I don't know if that makes sense. Are you with me?
Okay, yes, I'm with you.
So
Okay,
that's
it's
just
like
basic. Yeah, continue. Continue. Because you guys really need to understand this small, basic concept. If not,
okay, so
there'll be
it's like
problem.
memory is not stored in our database, or it's stored
Exactly.
in a variable. For
Exactly.
storage now,
So
it is stored in our database.
exactly. Now,
Okay.
this is in terms of Web 2. So let's imagine the database Gongon is the blockchain, right? Your state variables are stored in that database, which is the blockchain. And your memory only exists like it's just like a temporary, your database creates a kind of temporary storage, right? While this function is being executed. After the execution of this function, it gets deleted. It's not going to be existing at all. It's only there to hold, to be a kind of placeholder where you can use to like change this state. You understand? I think
Yes, I
you,
get
you
it.
you guys you better understand it when we go into struct and mapping. Okay,
I have
so
a question.
yeah, go on.
Okay, can you hear me?
Yeah, I can hear you.
Hello?
Yeah, I can hear you. Go on.
Okay, from the code, right? You said if the function runs, then the variable is destroyed, right? Does that mean that the p dot name and the p dot age we assigned, are they also going to be destroyed? Like we won't have any.
No, this p dot name is just making a reference of this struct. Anyway, we'll get to that in when we explain the reference and value types. But just take this p, right, which is a variable that is stored in the memory temporarily as a kind of placeholder, right? It is the placeholder that is helping us assign these values into our struct. Remember, as I said, that memory only exists when a particular function is being executed, right? The memory
Okay.
only exists when this particular function is being executed, which means this P only exists to execute these functionalities. It only exists to assign these values into the struct. You understand? If the P is going
Yeah.
to change any of these states, it only exists to help us change the values of these states, right?
Okay.
After the whole computation is going to, it's not, let's say it's going to be destroyed. It's just that it's not going to be added to the blockchain. If you should check the transaction details of this P on your blockchain, if we are maybe deploying on mainnet now or any of the live testnets, the only interactions you see is just that we will know that, okay, this function was called and then this value was changed. The other thing is happening within P. We are not going to see it on the blockchain. You understand?
Okay.
Sorry, can I
Thank you.
ask one question?
Yeah, continue.
I don't really understand the function of the struct keyword or class or the please can you throw more lights?
So anyway, we'll still get to that, but basically, we've not gotten to data types actually, but struct is a specific kind of data type in Solidity that helps us define our own custom data types. You understand? Let's say now you are building a smart contract that you are building a decentralized autonomous organization smart contract, or maybe you are building a smart contract that is going to hold the values of you are building a voting smart contract that's going to hold the values of a particular voting whatever, right? The struct keyword is a kind of data type in Solidity that helps you like define your own custom data types. In your voting smart contract, you want to know the people that are voting, right? You want to know if it's a voting that is going to be maybe you pay money to vote or something like that. You want to know the person that is voting, how much they are voting, when they are voting. You understand? Every
Yeah,
single
yeah, yeah.
information you want to know about it instead of storing it manually to the state, which we all know the state variable, it takes a whole lot of space. It consumes a lot more gas. That is why we'll get to gas optimization much later. So instead of doing all that thing one by one, and start doing slot packing and all those stuff, the slot helps you to pack everything into one object, which is this person, right? So now if you want to start getting information, you can just do person.this, person.age, person.name, person.address, person.amount. You understand?
Okay.
So the
Yeah.
struct just
So
helps you like, yeah, continue.
so basically, it's just like JavaScript objects.
Well, I will not really call it I'll say the mapping is more of an object because it's the key and the value, right? Struct is just like struct. I'm not sure if I've seen this something like this in maybe it works more like the interface in TypeScript. I'm not really sure, but this is specific to Solidity itself.
I,
When
I
you talk
understand
about
now.
I
object,
feel like it's like a class in JavaScript.
Yeah,
no,
it's
it's not
close
a
close
class.
to class in JavaScript. It's close to class
Don't
objects.
make mistake. Oh. The only thing that is close to class in JavaScript is the contract keyword. Inside, when you create your contract, you create the name of the contract, and inside your curly braces, right? You start all the whole computations and everything you want to do within that curly braces. But instruct, right? The naming convention is the same. The name is the same, but inside of what is inside here, you are not doing any computation. You are just like saving data or mapping certain data to something. It's just like,
Excuse, excuse me. Excuse me.
yeah, come on. Okay,
Um, i-
carry on.
inside these structs now, can you also maybe save a function as part of the data?
No. The only thing that can be saved inside of the functions are like variables, right? You could have a uint type, a string type, an address, even mapping. You can save a mapping inside of struct itself. You understand?
Yeah.
So uint 256 to maybe another uint 256, right? Then you just put the name. ID. So this so far, I'm not an expert in Solidity, but so far, these are the only thing you can see inside of struct. It helps you like pack variables and put them inside, like pack variables and put them together somewhere. So let's say now you are building, let us say you are building a registry of persons, right? And we have a function to set person, right? And we have 100 people that have interacted with this function. You know that inside this function, we are creating a reference of this struct using the mapping. Remember, the
Yeah.
mapping is a kind of key. It's a kind of it's a kind of functionality that helps us to like map values in a key value pair. So we call this is how you instantiate a struct using mapping in Solidity. The name of the mapping in your square brackets, you put in the value. Remember that you put in the key. Sorry, remember the key here is supposed to be an address, right? The key
Yes.
here is supposed to be address, and it's supposed to be pointing to this struct. So in Solidity, this is how you get the address of the address that is currently calling this function or interacting with something. This is just how you get it, msg.sender. So now, as we have set this, we know that this particular sender is going to have this particular value. Now we are instantiating this struct, setting it to memory and setting it to this value. This creates a reference of person, right? Whenever you are creating reference in Solidity, in programming actually, you are creating a copy of something. You are creating a copy of something, be it a value, be it a variable. You are creating a copy of a variable. And now we are now assigning these values to this particular variable, which means this particular address here, we want to assign this address or the variable that is inside of person. You understand? So we've set it to, we've set his age to be this, we've set his name to be this. So this is for the, if like 100 people interact with this particular function, we have 100 different addresses that are going to be assigned different values. So in our front end now, we could maybe want to search the value of a particular address. If we input the address here, it is going to return all these values for us: the person's age, the person's name, the person's every other information. I think let us even go straight. Let us do.
Sorry.
Yeah, ask your question.
Can you scroll up, please?
Yeah.
Hey, please, can you just like, what is the purpose of this set person function? Please don't be offended.
Set person function. No problem. So the function is basically helping us to populate this struct. So this struct, it basically contains information of a particular person, right? So this function is helping us populate the struct. If you look closely, you see that the function is taking in the age parameter and the name parameter, right? Then inside of the function, remember, we are creating a reference of the struct data type. When we create a reference inside of memory, we're assigning it to this particular variable. Remember that any variable that is assigned the memory keyword is being stored in the contract memory, which is not stored. It only exists when this particular computation is being carried out.
So, excuse me. Now, here that you used person and then memory. Are you hearing me?
Yeah, I'm with you. I can hear you.
Okay, I'm just trying to know whether I have understood maybe this code syntax or something. So now, since you declared a person data type, right?
Yeah.
You declared a data type called person, right?
Yeah.
Now, and normally, if you want to declare a variable, you start by maybe declaring the data type you are trying to. Yeah, you declare the data type that the variable will hold, right?
Yeah, I can hear you.
I said if you want to declare a variable, you have to declare the data type the variable holds, right?
You have to declare the data type, the visibility,
variable.
and the name of the data type, the visibility, and the name of the variable.
Okay, and that's why you have to say person and then memory and then p, right?
Yeah. So the struct, like I said earlier, it helps you create custom data type. So with this struct keyword now, you have created this person to be a data type.
Yes.
You understand? So that is why we are putting this as the data type. Then this one is the memory, which is it's supposed to be stored in the memory for us to do whichever computations that we want to do.
Okay, I think I understand it better now. All right, thank you.
Yeah.
Sir,
So
hello, sir.
yeah, I'm with you.
That doesn't mean anytime we write P, it tends to refer to the person that has been saved in the memory. That means when the P dot age, you populate the struct of a person. That means P dot age. Let's say P dot age of 29. We've inserted into that struct of that data type person.
I did not get your question, but you know this thing now we have instantiated this particular variable to be P, right? 1 second. The word is not visible. Anything. Okay. We have created this variable, right, to be p, and this p now already has all the functionalities or all the properties of this particular person. Are you with me?
Yes, I'm with you, sir.
Hello? So
I'm with you, sir.
by referencing, this P is already creating a copy of this person data type. This person data type already has these properties. So now, using this particular data type to instantiate a new memory variable, you already now have access to all the whole, you can see its functionalities in this particular struct.
Okay, thank you. Yeah, I think I've gotten it.
So now p dot, it's already showing me all the functionalities I could use. I could say p dot age and say it is equal to underscore age. Right?
Sorry, one more
And
question.
say, yeah, continue.
These people, I don't know, is there an array or what? These people that's started with small letter P.
No, it's a mapping. It's a mapping that's it's just like a functionality that helps us keep track of something in a key value pair. So this mapping now in this contract context, it helps us to keep the track of all the persons that are interacting with this set person function. You understand? It is taking a key value pair. You know how I think it's dictionaries in Python and how objects
In JavaScript.
work.
Okay,
Yes, in
that means it's an
JavaScript.
array in
Yeah.
JavaScript.
You can what?
If
Hello?
it's a dictionary in Python, that means I'm going to say
Yes.
if it's a dictionary in Python, that means is it an array in JavaScript?
No, array in JavaScript, just like, you know how this thing works. I don't know what they call it in Python, whether it's a dictionary. In this thing that, or is it tuple? I don't know. But when you have your curly braces inside of it, you can have something like name. You understand?
It's
Mr.
either tuple or dictionary in Python.
Yeah, I don't know what. I'm not a Python person. So this is just how, just like primarily, not really, but let's just put it like,
But
let's
my
assume this is what Python is doing. It's
sorry, I don't
mapping
think you answered
everything.
my question.
Okay, what's your question?
What's actually the function or purpose of the people mapping syntax?
That's what I'm saying. It's helping us to keep track of all the addresses. It's helping us to like keep track of information about this struct, right? In a key value pair.
Okay,
In a
now.
key value pair, which means that a particular key will give us
Yes.
a specific value of this person, right? This is an address. This one now is saving information in an address to person information. So let's say, for example, now I come with my address, right? I interact with this function. I put in 20 and I put in my name. Now, what the thing is going to do, because this msg.sender is already taking it is already taking my own address, right? Remember, this is how we are instantiating it here. The people, you put it, then your square brackets with whichever information you are putting. Remember, the people is going to take in an address. That's why we are putting an address here. So we are now instantiating it to this particular struct stored in the memory and assigning it to P. So what it's
So
doing
P,
now is my own address. Yeah, my own address is going to return all these values, right? And another person's address will return a different value that he inputs here.
okay, can I say this now?
Yeah, continue.
So P variable is going to be a P value pair of an address and other details like age and their name, right?
Yeah, exactly.
Okay,
So
I
one
understand.
second, let me see if we can.
So with your explanation, I feel like the struct is an array and we are mapping through the array to get the details of that particular wallet address. I don't know if it's acceptable.
1 second. So let's remove all this other stuff because it's already creating a getter function for us, right? Actually, you can actually say it's an array because you know how arrays work, right? In an array in JavaScript, everything has an index, and if you want to like get the information in a particular index in an array, if you say index 0, it will return the value of index 0
Yeah,
to you,
exactly.
right? So exactly that is just exactly what Python and the mapping is doing. But this time is not really dealing with indexing. You can use any data type as the key, right? Let me show you how it works exactly, because these things it's more better with practical. So you compile and you come here and you deploy. So what are we deploying? Example, okay. So remember, this is our struct. This is the mapping that is keeping the key value pair of our struct. And this is the functionality that helps us set value to each addresses that is interacting with our function, our contract, right? So in this set person's function, we are asked to provide the age. Let me say 20. We are asked to provide the name. Let me say Musa. And what is going on? And then we click on transact. It has gone through. Now, if I want to, using this mapping, if I want to view the value of this particular of this particular address now that interacted with this set percent function, remember that this is the address that deployed the contract. That's this is the address that's currently interacted with that particular function. So if we put the address here, you can see it will return the value for us, the value stored in the struct for us. Again, the structs help us define a custom data type. Inside of the custom data type, you can now have different information for this particular data type. The mapping helps us to keep to store value, to map every key to a value. Now we are mapping addresses to this custom data type we created here. And this function is helping us populate the information inside of the data type by this particular address. We could decide to use maybe index, actually, maybe a uint 256. And then we can now say, okay, based on ID1 or ID2, bring in the value that is in that particular ID, just like you said, like we have an array. But instead of using an array, we are usually Solidity developers, we are used to using mapping because that way is easier, right? You can decide to make things easier for you using an address. So that's basically how things are. If I should decide to change to this address, right? Remember what the first address is giving us. For the first address, these are the information that the struct helped us to save. Then I changed to this account now, which is a different address. And for this account, I want to put the age to be 40, and then I want to put the name to be Ima. Right?
You enter 400 instead of 40.
Okay, sorry. 40 and the name to be Ima. And then if I transact, right, you see that it has taken this address and assigned this information to this address using the mapping. You understand? Remember, this is the mapping. This is the name of the mapping. The mapping needs you to put in an address and then assign value to it. Here, we are putting in the address here, and then we are assigning it the value of P. And now this P referencing, right? It's referencing this struct. And then we are now pushing in all the information inside there for this particular address. So that's what we just did here. So this is a different address, and if I could copy the address and search, I should copy the address and search, it will return this value for us. Are you saying it's 40 Ima? It does not mean that the first one was deleted, because this is stored to our state. If I should go back and copy the first address, right, and paste it here, then click on this function, it will still return that value for us. Do you understand? So basically, that the struct helps us to, like, in a larger scale application where you have multiple people interacting with your with your contract, right? It helps you to, like, serialize things, to, like, store things in I think the only way you can do that kind of things, like in JavaScript, is like through arrays, where you can have maybe an array of user objects. Does that make sense? An
Yes.
array of user objects. So you have maybe an ID. The first user is going to have an ID of 1. His name will be Musa, his age will be this, depending on what your front end passed to your back end. But here, it is storing it in a mapping. So it's already stored in the struct. Then through mapping, you are, like, how do I explain? You are, like, pushing in values to those key. That is how mapping and struct work.
Okay, one more thing, please.
Yeah, go ahead.
Yeah, to be sure that I understand this, please can you share the screen again, the code?
Okay, 1 second.
It's about this MSG sender. It's a global variable, right? If I'm
Yeah,
correct.
it's a global variable.
The MSG itself, is it an object?
No, it's not an object. The MSG, this is just
Yeah.
like a message, just like a short form of writing message. It's not an object. It's just like together like this as it is. It is a data type. It's a global data. It's a global data type. So
And
we have the MSG.sender. You have the block.timestamp, which gives you the time, like the
so
time
this
that thing is happening.
so this MSG sender now is where the address is, or it references the address.
Yeah, it's referencing your address with whatever address that is interacting with this function. It is
Yeah.
helping us get that address. You know that I changed the address here, and then it saved it for me. I changed it to another address. It still saved it for me. That is what the MSG.sender is doing. It helps you get the address that is performing this, that is interacting with this function at that particular time.
Okay. And after everything, it gets stored in database or in the blockchain.
Yeah, after everything, it saves it to the state. Usually, state automatically are stored on the blockchain permanently.
Thank you.
You're welcome. If there's any question, please ask, because these are even the, like,
Okay,
simplest
so
thing.
is it safe to assume? So please share the code.
Okay.
Okay, is it safe to assume that it's like a constant for getting the wallet address of that particular person using the smart contract at the set point in time?
Sorry, can you come again? I was breaking. My network.
Okay, I said, is it safe to assume that it's like a constant to get the wallet address of the particular person using the smart contract at a particular point in time?
Exactly. It just helps us to get the wallet address of whoever that is using this function at that point in time.
Thank you.
So, is there any other question concerning the constants, the immutable, the state, the state variable, and these two type of data structures we have now? If there's any question, please ask, because it can be very confusing. If you don't understand the basics, it can be very confusing when you're building larger scale smart contracts. Okay, let's move on. I want to at least finish up this one first, the value type and this thing. So basically, the value type is just like it stores the actual value of the variable. When you assign a value type variable to another value or pass it as an argument to a function, a new copy of the value is created. So any modification made to the copied variable will not affect the original variable.
Sorry, you're breaking.
Can you hear me?
Yes, I can hear you.
I hear you now.
Okay, so I repeat, a value type in Solidity, when you ask, it's just like they help you store the actual value of a variable. When you assign a value type variable to another variable, right, or pass it as an argument to a function, a copy of the value is created. So any modifications you make to the copied variable will not be affected by the original variable. So when you're talking about value types in Solidity, you are like making a copy of a variable. And when you make a copy of a variable and you do any modification to the copy and not the original, it's not going to affect the original. It's only going to affect the copy of that variable. So let me do a very simple example, a very, very simple example. And I will give you a resource where you can read. So let me see you into okay. And see that we've created a copy of this value, right? We've assigned the age of Musa to Amaka. Now, if we should do any modification, let me see, I want to do any. Okay. So this function is supposed to increment Musa's age. And I have another function that's supposed to decrement. Right? So what's her name again? So you have Amaka age. All right, let's deploy the contract again. This is an example. I'm using this one as the example of the value type. This one's with the struct and the computation here is I've already used it to explain the reference type, where if you change the copy, if you any modification made to the copy, automatically affects the original data, right? Now this one, I want to use it to explain what how value types works in Solidity. So let me delete this contract that we deployed and let us use another address. And then we are deploying. Where is Musa? So this is Musa age, right? It is 10. Amaka age 2 is 10. If I should decrement Amaka's age, remember Amaka's age is the copy of Musa age. If I should do a modification to Amaka age, which is the copy of Musa age, is not going to affect Musa's age. That is what we mean when we talk about value. You create a copy, and whatever modifications you make to that copy only affects the copy, not the original. So let us decrement Amaka age, right? I click on decrement Amaka's age and click on Amaka's age. Amaka's age is 9 and Musa's age is still 10. Are you guys with me? If I should click on Amaka's age again, Amaka's age is 8, which is the copy of Musa's age. Musa's age is still 10. If I should increment Musa's age, Musa's age is 11. Amaka's age is still 8. So that's just the difference. In value types, when you create a copy of any variable or data and you make any modifications to the copy of that variable or data, right? It only affects the copy. It does not affect the parent data. But in reference, which is what we did here, I did the example earlier and you guys saw it. We are creating a reference. This with this p person memory p, we are creating a reference of this variable, and then we are modifying p. You can see that we are modifying p, but the modification we are doing to p is also affecting the struct of person. So that's just the differences between reference and value type. And here you can see the data types that applies for value types and the data types that apply for reference types in Solidity. So you can apply it to ints, addresses, Boolean, fixed size arrays. Then the reference types are mostly fixed size arrays, dynamic size arrays, byte arrays, then compose, which are your struct and mapping. For this example, I used the struct and mapping for this particular example. So is there any question in this one? Hello?
Yes, we are with you, sir.
The
There's
time
no
is almost
question from
up.
my end.
I think.
Yeah, there's no question, sir. We understood it.
Okay. So let me. Oh, there are too many things. I don't know. Darlington, are you with me?
Yeah, I'm here. I'm here.
I think. Are we? When exactly are we? Is it 9:30 or when?
Yeah, it's supposed to be 9:30. I think we are pretty much behind schedule already. We've exhausted time, so we could actually pause here if you don't, to probably continue in the next class.
Okay, let me just finish. Let me just finish this one. I think so. The next one will just move on to function modifiers. How to declare and initialize arrays in Solidity. So Solidity comes with two flavors of arrays. So it is useful to understand the different ways in which they can be declared and initialized. The two main types are fixed size arrays and dynamic size arrays. Fixed size arrays are passed by value, copied when passing around in the code. Remember what I explained about value types. Dynamic sized arrays are passed by reference. A pointer to the memory address is passed around in the code. So they are always different in their syntax and their capacity, which then dictates when we would use one versus the other. So here's an example. Here's what a fixed size array looks like when declared and initialized. So basically, this is how you declare a fixed size array in Solidity. This one now is like a fixed size array of strings, a fixed 6-length array of strings. So whatever you want to put inside this fixed array, right? It should not be more than this the size that you've assigned to it. And this is how you start assigning values. So the fixed size array at index 0, you assign it. The fixed size array at index 1, you assign it. At index 2 equals to at index 3 is equal to, once it's up to that size in which you've specified it, you cannot add any other thing to it. You understand? And you cannot use the push, because push is just like a way you add extra values or extra size to an array. You guys should understand how push works in JavaScript now, right?
Yes, we do. I do.
So you cannot do a dot push to a fixed size array. You understand? Because a fixed size array is just like you are creating an empty array with, like, it already has the in. If you are creating a fixed size array of 6, it's already populated actually. It already has the index 1, index 2, index 3, index 4, index 5, and index 5. You understand? So all you need to do is just to, like, say the name of the array in index 0 is equal to, that way you are just assigning value to each of the indexes. But if you do dot push, it's just as if you are adding more values to the end of it. So dot push does not work for a fixed size array. Then in contrast to that, we have a dynamically sized array that are declared and initialized as follows. Its capacity is unspecific, and you can add elements using the dot push method. So this is how you specify a dynamic array. Just the uint, then the array symbol and the name of your array. Then you start using your dot push to add stuff to your array. You understand? So you do your dynamic array dot push one, dynamic array dot push two. That is just how it works. I think we'll be stopping here for now. Function modifiers are just a way to, instead of using that require, you just modify things for you. So function modifier is just a way to like do the whole authorization thing, authentication and authorization within your function contract call. If you are creating a particular function that you want only your owner, you want only your owner to be able to call that function, then usually you can do your require. This require just a way to authorize some kind of behavior in a specific function. You could do your require that msg.sender is equal to the owner. This owner, assuming you've saved the value of the owner somewhere in your state. So if this pass, the function runs, right? If it does not pass, it reverts with an error. So instead of doing this require inside of your statement, in fact, inside of your function, you declare a modifier function with the name, and inside of the modifier, you write the authorization logic that you want, right? And then inside of your function, when you declare your function, you just use this only owner here, public, and then the only owner. So whenever somebody wants to interact with this change owner function, the contract automatically first checks if the person's address is the owner, because due to this only owner function here, it is going to first run this thing here before it runs whatever is inside of it. So that's just like a way to like control authorization. Because you could have in your function, you could have in your smart contract, you could have a function that is maybe to burn tokens, maybe to blacklist certain addresses, maybe to change the owner of that smart contract. And if you don't put all these checks in place, they will hack you out. They will hack your contract. But anyway, this is from the next class, we'll start from here with examples, then we'll move on to error handling, look at the differences between require, assert, revert. Then we'll move on to inheritance in Solidity, which is like a core concept in object-oriented programming. Inheritance with constructor parameters. So type conversion and typecasting, where you can change certain values to other type of values. How to work with floating point numbers, then the hashing, encryption, decoding, encoding, all those, how to use call contracts and fallback functions, how to send and receive ether, right? In case you want to create a contract for those things. Then Solidity libraries. I think after that, that's all. Yeah, events. And so in the next class, we'll look into it. I believe with this very simple example, I'm sure that you must have already understood how this thing works, the Remix IDE. The most important thing is this is where your file is, just like how you have your usual Visual Studio Code stuff. You have the file, you have your different folder structure, your search, your compiler to select a compiler version based on whichever version is specified here. Then this is basically where you deploy, right? So before we close, let me just show you how the deploying with your normal this thing works. So I want to deploy this contract now with my address, right? I already have like 3. It's already showing me the balance because I've already connected. So then you'll click on deploy and to ask me to confirm. This is exactly what's happening when we're using the normal Remix VM addresses. It's just that this is like working within the Remix let's say within the remix environment. So, but this one, let us deploy it to the live network. Okay. So when you deploy it on live network, you can see it here. It's still processing. Yeah, success. You can see the block number, the contract and everything. So you can look at the contract address here and see all the functionalities that are being implemented. And the good thing about Remix again is that it provides you with the interface where you can easily interact with your smart contract, right? For if you click on decrement amount now, you confirm, and the thing will like send the transaction to the live network. So this is basically the same thing that is happening when we're using the normal Remix account. And just want to show you how this thing works. So as people are interacting with your smart contracts on the front end, you can see everything from the back end, from the blockchain itself. So that's basically it. Hasn't it confirmed?
I have a question.
Yeah, go ahead.
Okay, how do we keep track of our remix code? Because I did not see any sign in when I opened the website.
So it has confirmed, you can see it. So he said what, sorry?
Said, how do we keep track of the remix code? Because I didn't see any sign up when I opened the website.
No, there's no sign up. There's no sign up. Once you just create, once you go to the remix.ethereum.org, it just opens up this environment for you. Although you could have maybe test files here, the storage owner ballot, then you can just click on create new file, give the file a name, .sol, which is the extension for Solidity, and then you
Okay,
are
so
in.
if I should close this and open this again, I will still get my codes.
Yes, to be sincere, I really don't. It's been a very, very long time since I worked with Remix, right? The first time when I was learning Solidity, if you write your contract in Remix, save it, do everything you want to do, and close your system. Tomorrow, if you open your system, like you won't see that contract again. But I think they said they've like fixed that stuff. I'm not sure. I don't know. I usually code with my IDE, but in case of that, just copy the code
Because
and
I
paste
just
it in.
switched browsers and I'm not seeing my codes in.
Okay, let me just sorry, let me just come in here. Basically, what happens with Remix is there are no sign-in, there's nothing like that. Basically, everything is saved to your browser's local storage. So, in as much as you're using the same browser and you've not probably cleared your cookies and all your browser storage, you'll always have access to all the contracts you've previously written. But if you maybe change your system or change to another browser, you'll not have access to all those things because there's really no way to track who owns what. But everything is just stored to your browser's local storage.
So sorry, there's no way to maybe save the code to your local storage or export the codes to somewhere like GitHub or something.
Basically the essence of Remix is not for you to do all this you can actually I think there's a github extension you can use with Remix to probably save your codes on something like GitHub instead. But as we go forward, right, you would realize that most of your main developments, right, you do them with like a local framework like Hardhat, Foundry, and the rest, where you have everything stored in your system and you can decide to move them to GitHub at will. But things you probably do with Remix, right, is what I use Remix for mostly is for experiment. So I probably have this idea in my head and I want to experiment to see if it's viable, right? I'll just use Remix to test it out. So basically, you don't do serious thoughts in Remix.
Yeah, thank you very much, Darlington. So the REM is just like a developer environment to like test out stuff and learn stuff.
Excuse me.
Um,
Excuse me.
Hello?
Yeah, I have a question, please.
Yes, go ahead.
You said something like you use your own IDE when you're writing smart contracts. Yeah. So which IDE do you use, please?
I use Visual Studio Code. Um, I use Visual Studio Code for my own stuff. So in your Visual Studio Code, you can actually download an extension for your Solidity, right? And whenever you write your Solidity code, you can always come back to it. But as Darlington said, the remix one stores everything in your browser storage. So
Thank you.
I'm looking for one of these projects I did. So this one let me show you how it works quickly. Okay, yeah, so this is one of it. This is one of the contracts in this thing. You have your Solidity extension where you can, as you are typing, it will basically be showing you um like how extensions work actually to help you highlight certain things and all the whole syntax and make sure everything is perfect. So that's just it. If you want to test out things with your remix and want to still have access to it, I think you should not clear your browser cookies like Darlington suggested. Or after testing and you want to sleep, just copy everything and paste it in your VS Code or somewhere else so you could come back and try, because it happened to me a lot while I was still learning the whole Solidity stuff. After writing code, you come back and you can't see it anymore. So yeah.
Let's continue our discussion of
So you actually also read this, the reference and value types, and the remix IDE stuff. You can just go to remix.ide.pro. That'll be it for today. Thank you everyone for the time and attention. Hope to see you next week.
Yeah, thank you so much, Chidera. We greatly appreciate this. Has been like 2 hours of intense study, right? We greatly appreciate your effort. All right, thank you so much, guys, for sticking around. I mean, like we started about I think about 25%, but we are 15. I mean, you guys are the real MVPs, and definitely, if you can just continue like this, I'm very sure your efforts will not be unrewarded. Basically, before we go, right, I will initially I want to release the results for the classwork, but something I would rather do is I'm just going to go through the classwork again. Some of us made some very dire mistakes. There are some certain mistakes we made which I expected we'll make though, and I want us to make corrections to these, right? So we're just going to quickly go through that and then we'll call it a day for today. So let me just quickly share my screen. Right, you guys, you guys can see my screen, right?
Yes, we can.
Right. So,
Yeah, we can see it.
yeah. So we got a total of 27 responses, and this is just like a summary. So we're going to just use a summary. So for definition of the blockchain, right? A lot of you guys defined it very beautifully, but my problem was a lot of persons were using ChatGPT to define blockchain, and I don't really want us using ChatGPT to do assignments, because if you continue that way, you won't learn anything. I explicitly stated in your own words, because one of the best ways to know you've understood the concept is that you can literally close the book and say it in your own words without trying to like requote the author of the book or try to use the help of Google, because I mean
Hey,
this
cast the
is
person now. Cast the person name now.
let's just who did it. But please, guys, if you are giving assignment, try to do it from your head. It wouldn't. I just want you to show me that you actually understood the concept. It's not a matter of English. Once you there are certain concepts you use, I would know that okay, you really got like a good understanding of the topic you're trying to talk about. Right. Let's. The next question was, what here is not among the aforementioned important properties of the blockchain. When we talk about blockchain, right, we clearly talked about decentralization in the first class. Said decentralization is important. We talked about distributed. It has to be distributed, right, among different nodes. And we talked about immutability. So definitely things you put on the blockchain has to be mutable. So these are the three most important properties. Of course, speed is a necessity, right? With blockchains, we want to have speed, but those are that is like the was not one of the important properties we talked about in our first class, right? We'll talk about how we can achieve speed when we go into the scalability trilemma, trying to help the blockchain achieve both decentralization, security, and scalability, without being one of our very, very future classes. Then this other question was the question literally we had over 87%, close to 90% filling this question. That's totally two important components of a consensus mechanism. I intentionally put proof of work and proof of stake because I knew that a lot of persons still make these mistakes, right? I clearly stated during our second class that while proof of work and proof of stake are like when we talk about consensus mechanisms, these are the things that first come to mind, right? They are colloquially referred to as consensus mechanisms. They are more or less like a component, not exactly a component, but they are part of they are a type of is CBU resistance technique within consensus mechanisms. So consensus mechanisms are made up of two very important properties. We have CBU resistance and chain selection, and as you can see, there was just 11.5% who got that question right. So proof of work and proof of stake are types of CBU resistance mechanisms. Then we now have chain selection rules where you can have stuffs like the longest chain rule or selection by chance and the whole rest of them. So the answer is severe resistance and chain selection, and majority of us feel that. Please let's take our correction. Then how does the proof of stake consensus mechanism work? There's a lot of documents. I shared the Ethereum book with us. I shared the official Ethereum docs. You could make reference to that and try to understand it. As always, again, people use chat GPT for all these things. When I see something that is written with chat GPT, I don't even need to like just by reading the statement, you already know how ChatGPT writes things, and please let's try to avoid that. Then the next question: why can't you run smart contracts on the Bitcoin blockchain? So it's because Bitcoin has no virtual machine. We stated it's right, similar to Ethereum virtual machine. At least we had 74.1% getting that right. So if you didn't get that right, please take the correction. Then how many Ethereum do you need to deposit to participate as a validator? At least we had over 90% getting this right. So you need 32 Ethereum to participate as a validator on the Ethereum blockchain. Now, over to the next question. Who coined the word Web 2? I thank God nobody. Okay, you guys don't rate me in this class, shall because not even one person said decided to pick my name, but it's fine. It's all good. But the answer is Darcy Dinusi. A lot of us got that right. That's the answer. Then what happens to malicious validators in the proof of stake system? So the answer is their stakes get slashed. We had 51.9% persons getting that right. So that's just the answer basically. Malicious validators get their stake slashed. Then what chain selection rule does Bitcoin use? Bitcoin uses the longest chain rule. The longest chain rule. I think 92.6% of us got that right. Then if you are looking for an explanation to how the longest chain rule, you could just search on Google, you find an explanation. We can't go into that again. I'll make a reference to the previous classes. Can't go into that again because of time. But I hope that by looking at this, right, we can already grade ourselves in our head. So please, guys, the place you made mistake, please just try to take note of it. And I'm begging you in the name of God again, don't do the next assignment to ChatGPT. God bless you.
Thank you.
Thank you, sir.
Thank you, boss.
Right. Thank you so much,
Thanks, boss.
guys, for coming. Yeah, you're welcome. Thank you so much for coming around. And I think we would call it ED here. Let me just stop this recording.